It is late summer, AD 232, in what is now New Zealand. Without warning, a 40-kilometer-high plume of volcanic ash rockets into the stratosphere. The sheer weight of that massive eruption column eventually overcomes its upward momentum. It collapses back to Earth, transforming into a pyroclastic flow, a dense, fast-moving avalanche of searing gas and rock. The scale of the resulting destruction is difficult to comprehend. This frictionless 500 degrees Celsius flow annihilated 20,000 square kilometers of land in under 15 minutes. The global impact was immediate. The event ejected 120 cubic kilometers of pumice and triggered a global volcano-meteorological tsunami, a shockwave generated by the collapsing ash column that displaced the atmosphere and sent waves across the planet's oceans. Today, the massive crater left behind by that catastrophe is New Zealand's largest freshwater lake. This is Lake Taupō. To understand how such a serene landscape conceals the world's most powerful eruption of the last 5,000 years, we must dissect the unique geological engine buried beneath the water. A supervolcano is defined by a massive, sponge-like underground magma chamber. When that chamber empties during an eruption, the overhead ground collapses into the void, forming a giant basin called a caldera. The globally familiar baseline for these systems is Yellowstone. Its engine is a hotspot, a stationary region of melting in the Earth's mantle that acts as a thermal blowtorch, melting the crust as tectonic plates slide over it. Yellowstone is currently a mature, older system. Its magma reservoir is largely solid rock, containing a liquid melt fraction of only 5 to 15%. But a stationary hotspot is only one way to fuel a supervolcano. New Zealand's Taupō system is built on a much more violent tectonic environment. Taupō's engine is not a hotspot. It is a subduction zone, a brutal geological boundary, or one of Earth's tectonic plates is being forced deep beneath another. This process generates massive volumes of magma. As the descending plate sinks into the mantle, it drags ocean water with it, which chemically lowers the melting point of the surrounding rock and causes it to liquefy. This schematic shows the result, a subduction process maintaining a higher liquid melt fraction, between 20 and 30%. Above the magma reservoir lies the twin threat, an active fault belt where the crust is being stretched and pulled apart. These forces create a dangerous feedback loop. Earthquakes agitate the underground molten rock, making it more mobile and explosive, while rising magma lubricates the fault lines, triggering more frequent earthquakes. Taupō is a self-amplifying geological machine where tectonic and volcanic forces continuously feed into one another. In May 2022, that engine awakened. Taupō entered its most intense period of seismic unrest in recent monitored history. An intense earthquake swarm peaked with a magnitude 5.7 quake beneath the lakebed. The shift was so abrupt, it generated a lake tsunami, a series of turbulent waves surging from the epicenter. This bathymetric map reveals the physical impact. Near the Horomontangi reefs, the ground was pushed upward by 160 millimeters. Researchers traced this to new magma reacting with the older structural faults from the AD 232 collapse. While this activity is significant, volcanologists consider it normal behavior for an energetic teenager of a volcano. It is merely shifting in its sleep. Long-term hazard models reflect this. Currently, there is only a 0.08% probability of a massive super-eruption occurring within the next 500 years. Massive eruptions are rare, but Lake Taupō remains a living testament to the immense subduction forces constantly reshaping the Earth beneath our feet.